Hi, in this video I want to talk about digital to analog conversion. A digital to analog converter, as the name suggests, converts a digital number into an analog number. And that's what I have depicted in the slide here. So on the x-axis, you have the digital code. And as you know, the digital code is, you don't have all values of numbers represented. They are discrete numbers. So if you have a 3-bit code, you have 8 different numbers associated with it. And each of these numbers is then converted into an analog value. And usually, uh, this conversion, this digital to analog conversion, can just be depicted by a multiplication with a constant. So the analog value A is equal to some constant times the digital value. So for example, here, the digital value 1 is converted into some analog value called delta, and the digital value 2, which is 010, is converted into 2 delta, and so on. Okay, this constant that we multiply with the digital number in different implementations of digital to analog converters can either be a voltage or a current. So your analog value can be some voltage times the digital number, or it could be a current times the digital number. Uh, Many times, instead of actually referring this to this constant as the vref in an digital to analog converter, what we do is we refer to vref as the full range of the digital to analog converter. So vref then becomes, in this case, it becomes 7 delta. Okay, and then what you want to do is you divide it by the number of levels, which is 8, and your analog value becomes uh, a vref divided by 2 to the power m, where m is the number of bits of the converter, times your digital code. So instead of so this constant then is basically the whole range of your digital to analog converter divided by the number of levels. So this is also one way of representing the constant that we want to multiply the digital. That kind of represents the transition from the digital to analog values. So a variety of codes can be used in digital to analog converters. So we have already seen that you have a digital code and multiplied by a constant gives you an analog value, right? But what kind of code do we use? So you could use binary codes, which is basically the usual numbers 0001, 1011, which we have used usually. You could have something called the thermometer code. A thermometer code basically represents 0 by with all zeros, 1 with a 1 at the first place, 2 with ones at all the places till the second place, 3 with all the numbers till the third place, and so on. Or you could have a 1 of n code, and you can see how that works. So you can have different kinds of digital representations. And as we proceed in this data conversion lecture, you will see that in certain cases, certain of these codes are more important than others. So, in summary, what does a DAC do? It takes an input, a digital value, multiplies it with a constant, and gives the output. And this output then is an analog value.